Have you ever pondered the enigma that is quantum physics? Today, we're embarking on a journey to unravel this mystery. Quantum physics, a revolutionary field of science, is not just your run-of-the-mill concept. It challenges the very foundations of our understanding, questioning the traditional scientific thinking we've been accustomed to. It's a realm where particles exist in multiple places at once, where they teleport, and where the mere act of observing can alter reality. It's like peering into a looking glass, where the world as we know it is turned on its head, and the impossible becomes the norm. As we delve deeper, you'll discover that quantum physics isn't just about complex equations and technical jargon. It's a fascinating world that's waiting to be explored. So buckle up. Now prepare to step into the captivating world of quantum physics. Let's start with something called the photoelectric effect. Imagine you're sitting in a room with a metal lampshade. Suddenly, a beam of light hits the shade, and just like magic, it starts to generate electricity. This isn't some fairy tale, it's real, and it's called the photoelectric effect. You see, when light, which is made of tiny packets of energy known as photons, hits a metal surface, it can provide enough energy to kick out some of the electrons in the metal. When these electrons, which are negatively charged, escape, they create an electric current. But here's the fascinating part. Light doesn't act only like waves spreading across the room. It also behaves like particles, those tiny packets of energy we mentioned earlier, and each photon carries a specific amount of energy related to its color, or more scientifically, its frequency. With the photoelectric effect, we see a beautiful marriage of light and electricity, two fundamental aspects of our universe, and it's all thanks to these tiny energetic photons. So, light isn't just light, it's also a stream of tiny energy packets called photons. Now, let's leap into another fascinating phenomenon, quantum jumps. This concept sees electrons moving between orbits in an atom, but not in the way you might expect. Instead of smoothly transitioning from one orbit to another, electrons make instantaneous, discrete leaps. Imagine a dancer spinning on a stage, then suddenly appearing at the other end without crossing the space in between. Quite a mind-bending thought, isn't it? This quantum leap or jump is a core principle of quantum physics, and it's as mysterious as it is intriguing. It defies our everyday understanding of motion, where we expect a clear path from start to finish. But in the quantum world, things play by a different set of rules. When an electron absorbs or emits energy, it can jump from one energy level to another, like moving between different rungs on a ladder. But here's the kicker. It doesn't climb the ladder rung by rung. Instead, it teleports from one rung to another with no middle ground. Just like that, electrons can leap from one orbit to another without any transition in between. Imagine if particles could communicate instantaneously, no matter how far apart they are. Welcome to the world of quantum entanglement, the closest thing to telepathy that exists in the universe. Picture two particles born together, twins if you will. Even when separated by vast distances, they remain interconnected, sharing a mysterious bond. If you were to measure one particle, you'd instantaneously affect the state of its distant twin, no matter how far apart they are. It's as though they're in a constant, instantaneous conversation, a phenomenon that Albert Einstein famously dubbed spooky action at a distance. Yet, this isn't just a theoretical concept. Quantum entanglement has been experimentally verified multiple times. It challenges our everyday understanding of the world, pushing the boundaries of what we thought was possible. It's a reminder that the universe has more to offer than what meets our eyes. In the quantum realm, distance is no barrier to communication. The quantum world is indeed a mysterious land, one that continues to fascinate and perplex us with its strange yet beautiful phenomena. Quantum physics isn't just mind-boggling, it also has profound implications. Indeed, this revolutionary science does more than just challenge our traditional thinking. It invites us to reimagine our understanding of the universe itself. The quantum world is a mysterious land where particles can be at two places at once, where they can communicate instantaneously over vast distances, and where they can leap from one state to another without passing through the intervening space. Surely these concepts are bizarre, but they have been experimentally confirmed, making them not just theoretical musings, but concrete realities. So, what does this mean for us? Well, let's start with technology. Quantum physics is the basis of many modern technologies that we take for granted. Lasers, semiconductors, and even our digital watches owe their existence to the principles of quantum mechanics. and the future promises even more. Quantum computers, for instance, could perform calculations at speeds unimaginable with today's technology. But the implications of quantum physics go beyond the practical. They delve into the philosophical. How do we reconcile a universe that on the macroscopic level behaves according to the deterministic laws of classical physics, but on the microscopic level is governed by probabilities and uncertainties? This question challenges our very understanding of reality, and then there are the grand cosmological implications. If quantum mechanics applies to everything as it seems to, then it must also apply to the universe as a whole. This leads to the mind-bending idea of a multiverse, where countless universes, each with its own reality, coexist in a grand cosmic ensemble. The mysterious land of quantum physics continues to challenge and fascinate us. The journey into this enigmatic realm of physics has just begun.